An injection attack happens when an attacker tries to inject malicious code or commands into an application. This typically happens if the application doesn't validate user input before processing it. The injected code can then be executed, leading to a wide range of potential security issues. One common type of injection attack is a SQL injection. Using a SQL injection, an attacker is able to manipulate the SQL statements that your application sends to a database, allowing them to perform unauthorized actions or access sensitive data. Let me demonstrate this using the OWASP Juice Shop, which is an intentionally vulnerable web application that you can use to learn about many different application security risks. It can be found on GitHub. Users can log into this shop using their email address and password. In this scenario, a typical injection attack would be to manipulate the input and try to log in as a different user. This is the shop selling all sorts of juice. To log in, I can click on Account and Log in. Let's look what happens if I enter some fake data. It says invalid email or password. This email address is probably wrong, but how about finding one that might work? I'll quickly go and do some reconnaissance on the website. Maybe I can find something. Look at this. Somebody gave this page a 5-star review and the email address looks like it's from someone at Juice Shop itself. And this could actually be admin. So let's go ahead and try this address. And a random password, just to see if we get anything different. Nope, invalid email or password. Select everything from users where email equals something and password equals something. And the email address we sent through the login form is admin@JuiceShop. So in this case, let's try and add this here. But the problem is we don't know the password. So what we need to do is change the query so that it doesn't even check the password. And a way to do this is to add 2 dashes in front of the AND, so that the database thinks that everything behind these dashes is a comment and won't be executed. So the query will just return the record where the email is the one we entered. But how can we modify the data we send so that it adds these dashes? If we just add them to the email address, it would look like this. The dashes are inside the quote, and the database will think it's part of the email address and not part of the query itself. So this doesn't work. Now, how do we get the dashes outside of this quote? How about adding another quote as part of the email address we sent, like this? Let's paste it into the field, and we've got a valid query that only looks for the email address and ignores the password. Let's try this in the app. I'll paste this into the email field and click Login. That's different. Let's have a look at the account. And we are, in fact, logged in as the admin and have access to all their data, including addresses, payment options, and a digital wallet. As you can see, it takes the email and adds it to the query. And also the password, hashes it for security, and adds it to the query too. Then it sends the query using SQLize and transforms the result into a user model. If the user exists, they will be logged in. Otherwise, the app will return the message that we've already seen: invalid email or password. We can fix this by not directly using the user input and using query parameters instead. Let's replace the email and the password with question marks and add them as parameters to the SQLize query using the replacements attribute. This way, the query isn't just built from whatever the user enters into the fields. It is parameterized, and the database server makes sure that none of these replacements can be executed as part of the query. Let's go back to the shop, log out, and try to log in again with the same injection attack. Our random password, and we can see that the attack doesn't work anymore.